Hello, welcome back. The title of this lesson is called Metric Unit Conversions Part 1. So in this lesson, I'm really excited to teach you because we are going to be learning about what the metric system is, reviewing some of the units that we've talked about in the past. We'll be specifically converting from one unit to another, and we will be doing it using my method, which is using a unit conversion kind of table, which will also help us as we go into more math classes down the road. It really is one of the most important things that you can learn in math is how to convert units, because we use it in physics, we use it in chemistry, we use it, of course, in math, and we use it in every branch of science and engineering. All right, so before we get too far, let's just review and talk about what these metric unit conversions are. So in general, we're going to be talking about length, units of mass, and units of volume. And before I go any farther and actually talk about any of this stuff, I want you to look at the numbers in the tables. Forget about what they mean. What they mean doesn't matter. We have ones, 1,000, 100, 1,010, 1,000. You see all of these numbers are with 1 and some zeros at the end there. So that's called a power of 10. A power of 10 is 10, it's 100, it's 1,000, it's 10,000, it's 100,000, things like that. You can see that all of the metric system involves nice numbers, powers of 10. Now, in the future, we're going to be talking about the US system or the British system of measurement and converting between pounds and ounces and things like that. And when I show you the same table, the numbers will not look nice like this. They'll look weird and just random. And that is one of the main reasons we use the units of the metric system in science and engineering, is because all of the numbers are very nice and they're very simple to work with, all right? Now first, we want to talk about unit of length, and then we're going to go from there. So what is the unit of length in the metric system? The basic unit of length, you can see it in red here, is the meter. This is the basic unit of length. We're going to come back to what the unit of length of a meter, how we work with it later, but for now just remember the basic unit of length is called the meter. Then we talk about something called mass. The unit of mass in the metric system is called the gram. You see it is in red here. The basic unit here, we call it the gram. At least in this lesson, we're going to call it the gram. The paper clip that I'm holding up is 1 gram. And the basic unit of 1 meter is this stick here. All right. Now, exactly what is mass? Some people think it's the same as weight. It's not really the same as weight. The unit of mass of grams is telling you how much material is in here. It's kind of telling you how many atoms and what kind of atom. It's how much mass, how much matter is inside of this thing. Now, if I take this paper clip to the moon, it will not weigh as much, but it will still have the same mass. If I take it to Jupiter, it will not weigh as much, but it'll still have the same mass. If I take it to Neptune, it will not weigh the same, but it will have the same mass. So the mass of an object never changes, but when you go to different planets with different strength gravity, the force of gravity, the weight can change, but the mass never changes. The basic unit of mass is a gram. And then finally, we have the unit of volume. Unit of volume, it doesn't talk about how much matter is in there. It talks about how much space something occupies. How much space in our world does it take? The unit of volume is, the basic unit of volume in the metric system is called the liter. And this right here is 1 liter here. So if you can kind of imagine drinking something like this, this is 1 liter. All right, so those are the 3 main units that we're going to be talking about. Now let's go a little more detail here. You see this chart. We have meters, meters, meters. All right, we have to learn a little bit more. You see we have kilometer. Kilo, the prefix kilo means 1,000 of something. So 1 kilometer is just 1,000 of these things called meters. Kilo means 1,000, so that's very simple. You see 1 kilometer is 1,000 of these meters, right? 1 kilogram is just 1,000 of these little grams, which are these smaller units, the size, the amount of mass in this paperclip. 1 kilogram is just 1,000 of these things. 1 kilometer is 1,000 of these meters. So what do you think a kiloliter will be? It's just going to be 1,000 of these liters. So it's very easy to talk about small and large numbers in the metric system by using the prefixes. If I tell you I have 2 liters, you know it's something you can hold in your hand, right? If I tell you I have 2 kiloliters, then you know it's 2,000 liters because kilo means 1,000. And so you can easily talk about sizes of things just by the word. So that's kilo. Kilo means 1,000. 1,000 meters, kilogram, 1,000 grams, kiloliter, 1,000 liters, all right? Now let's talk about the prefix centi. When you see centi, what does it mean? It doesn't mean what a lot of people think it means. Centi means 100 times smaller. So when I say I have a centimeter, it means I have something 100 times smaller than a meter. You see, kilo means 1,000 times bigger than a meter, and centi means 100 times smaller. So on my meter stick here, see, here's a meter. From all the way here to here's a meter. But if you look closely, you probably can't see it on the camera. This meter stick is divided into 100 markings that go all the way to the end. Here's 40, 50, 60, 70, 80, and you have the numbers in here, and then 90, and then 100. So if you take this meter stick and chop it into 100 little pieces, one of those little pieces about the width of my finger, here, is called a centimeter. Centimeter is 100 times smaller than the base unit. Everything is related to the base unit. Here is a meter. Centimeter is 100 times smaller. Now, because centimeter is 100 times smaller, it takes 100 of these little bitty centimeters to make 1 meter. That's what this is showing you. 100 of these little centimeters makes 1 meter. Now, if that's what's happening for length, what do you think is happening in terms of mass, grams? Remember, the basic unit of mass is this paperclip, a gram. So if I have something called a centigram, it's 100 times smaller than this little thing, right, in mass. So it's going to take 100 centigrams to be the same as 1 gram, because these centigrams are tiny, tiny, tiny. They're 100 times smaller than this. So it takes 100 of these centigrams to make 1 gram. Same thing for liters. 100 centiliters, I need 100 of these tiny little centiliters to equal 1 liter. Remember, the prefix centi means 100 times smaller. All right? And then the last one, the last big one we're going to talk about is millimeters. I know everybody's probably heard of millimeters. So what does milli mean? The prefix milli means 1,000 times smaller, right? So 1 millimeter is tiny. Think of millipede. Think of centipede even. Right? Centipede's 100 times smaller. Millipede is 1,000 times smaller. So there's no way you're going to see this on the camera, but if you get an actual meter stick, there's little bitty marks across the top that you're not going to be able to see on the screen, but I can see them here. And there's 1,000 of these little markings that go all the way from here to here. So 1,000 of these tiny, tiny millimeters will equal 1 meter. And 1,000 of these tiny, tiny milligrams is the same as 1 gram. And 1,000 of these tiny, tiny milliliters is the same as 1 liter. So the main thing I want you to pull out of this is the base unit of length is this thing called a meter. And when we have a kilometer, it's 1,000 times the length of this, because a kilo means 1,000 times bigger, right? And then we have kilogram, 1,000 times of a gram, and then kiloliter, 1,000 liters. So kilo means 1,000 times larger than whatever the base unit is. Milli means 1,000 times smaller. So it takes 1,000 of these millimeters to equal a meter. It takes 1,000 of these milligrams to equal a gram. It takes 1,000 of these milliliters to equal a liter. And then for centi, it's 100 times smaller. So it takes 100 of these centimeters to equal a meter, which are these markings, the width of my finger is a centimeter. And it takes 100 of these centigrams to equal a gram, and it takes 100 of these centiliters to equal a liter. And then I have one more up here that we also use quite a bit as well, and that is that 1 centimeter is 10 millimeters. And you can see that on there. If you look at a centimeter on a meter stick, you can see that there's 10 little millimeter markings between there. So this one here is kind of separate from the others, that 1 centimeter is equal to 10 of these smaller things called millimeters. So now that we have all of that kind of background out of the way, we're ready to start solving our problems. All right, for our first problem, I want to start off with a unit of 5 grams. 5G means 5 grams. And I want you to convert that to some number of milligrams. Now, a lot of students, when they look at something like this, they just freeze up and they don't know what to do. The very first step is to know I want to go from grams to milligrams. And if you don't remember, then go back to the table. We go down to mass, and we're looking at grams and milligrams. So here's grams and here's milligrams. So if you don't remember, then you just look at the table. 1 gram is the same as 1,000 of these tiny, tiny things called milligrams, because a milligram is 1,000 times smaller than a gram. So to get 1 gram, I need 1,000 of these tiny, tiny things to get there. So 1 gram is 1,000 milligrams. Now, what you need to do is figure out a way to multiply or divide to make this thing work. This is how I want you to solve every unit conversion problem. I want you to write down what you have been given, 5 grams, draw a line under it, and draw a vertical line next to it. And right here, I'm going to write down 1 gram is 1,000 milligrams. Now, the way I'm going to write it down is I'm going to put 1 gram on the bottom and 1,000 mg, milligrams. This thing right here is the conversion factor. 1 gram, 1,000 milligrams. That comes straight off my chart. Now, I could write it like this. I could flip it over and write it upside down, but we are going to see in a minute why we're writing it this way. When we write it this way with a gram on the bottom and the gram on the top, the grams cancel each other. The reason the grams cancel each other when they're on the bottom and the top is just like fractions. When you have, a 0 on the top and a 0 on the bottom of a fraction that has numbers, you can cancel the zeros. Because basically what you can think about doing is you can divide the top by grams and the bottom by grams, and it gets rid of them. Just like any fraction, you can divide top and bottom by whatever you want to get rid of it. I could divide this by grams and this by grams, and it will get rid of the grams. An easier way to think of it is if you see grams on the top and on the bottom, you just get rid of them. Now, the only unit I have left is milligrams. So what this is telling me is that to go from here to here, I need to take the 5, multiply by 1,000, and then divide by 1. Everything on the top gets multiplied, and everything on the bottom, you divide by that. So what is 5 times 1,000? Well, the easiest way to think about that, you can write it down, 5 times 1,000, but just cover up the zeros. 5 times 1 is 5. And then since I covered up the zeros, I have to add the zeros back in. So it's 5,000. 5 times 1,000 is 5,000. The only unit left is milligrams. And I've divided by 1 here, which doesn't change anything. So what I've done is I've taken 5 times 1,000, and then I divided by 1. Now, I could go down here and write 5 times 1,000 and do it all, but I'm trying to also show you how to multiply and divide by powers of 10. When you multiply by a power of 10, meaning you multiply by 10 or 100 or 1,000 or 10,000 or 100,000, then it's very easy because all you do is ignore the zeros. 5 times 1 is 5, and then you add the zeros back in. So when you multiply by powers of 10, it's very simple. You just add the zeros at the end. When you divide by powers of 10, we'll see what we do here in just a minute. But for here, we are telling ourselves that 5 grams is 5,000 milligrams. Does that make sense? Well, I know here that 1 gram is the same as 1,000 milligrams. So if I have 5 of these grams, I must have 5,000 of these milligrams. And that is the final answer. As we go through these problems, I'll be able to do less and less and less talking. But here in the beginning, I just want to make sure everybody's on the same page. Next problem. Let's say I have 6,000 liters, and I want to convert that to kiloliters. Kiloliters. So I need to go between liters and kiloliters. So let's go back to our chart and think about it. We're looking at liters, and we're looking at liters and kiloliters. Now this is telling us that 1 kiloliter is the same as 1,000 liters. Now I'm using my chart, but actually once I start learning them, I don't really need the chart because I know that kilo means 1,000 times bigger. So 1 kiloliter must be 1,000 of these liters. So 1 kiloliter is 1,000 liters. Now, how do I arrange it? I first write down what I know, 6,000 liters, draw a horizontal line, and then draw a vertical line. Now, I know that 1 kiloliter is 1,000 liters. Now, I could put the kiloliter on the top or the kiloliter on the bottom. The way that you need to write it is that 1 kiloliter is 1,000 liters. Why do I write it this way? I could flip it over and have the kiloliters on the bottom and then the 1,000 liters on the top. But if I do that, nothing will cancel. You see, it only cancels if I have something on the top and something on the bottom. Liters will cancel with liters. If I flipped it over, nothing would cancel. I would have kiloliters here, and that would be wrong. So what is this telling me that I need to do? It's telling me that what I need to do is take 6,000 and multiply by 1. Everything on the top gets multiplied. Once I do that, then I divide by everything on the bottom. So what am I going to actually have? 6,000 times 1 on the top is 6,000. And then on the bottom, I still have to divide by 1,000. So here I have kind of a fraction, 6,000 over or divided by 1,000. So you can do the long division. You can write down 6,000, put your division house, divide by 1,000. You can do all that. Or you can listen to what I'm telling you about multiplying and dividing by powers of 10. Because here I have 6,000 on the top and I have 1,000 on the bottom. And when you're dividing numbers like this, if I have something on the top and the bottom, I can cancel. So anytime you have zeros in the top and zeros in the bottom, I can cancel this 0 with this one. This 0 will cancel with this one. This 0 will cancel with this one. And what will I actually have left? I will have a 6 on the top and divided by a 1 on the bottom. And so the answer will be 6. And the only unit I have left, because the liters cancel with the liters, is kiloliters. Now let's see if this makes sense. We know that 1 kiloliter is 1,000 liters. So if I were to have 6 of these kiloliters, it should be 6,000 liters. And so this unit conversion makes sense. Now, before I go to the next problem, I want to explain why this is okay. Why can we strike zeros like this? The reason is because this is a fraction. It's division, but we're writing it as a fraction. 6,000 divided by 1,000, or 6,000 over 1,000. I can simplify fractions by dividing top and bottom by anything I want. So if I take this top and divide by 1,000, and then take this bottom and divide it also by 1,000, 6,000 divided by 1,000 is 6, 1,000 divided by 1,000 is 1. So striking the zeros is the same thing as simplifying fraction. Divide by 1,000, divide by 1,000. And you can certainly do it that way if you want. But I'm trying to teach you to strike through the zeros because we're going to be doing that a lot more when we get into algebra and pre-algebra and other parts of math later. So that is, in a nutshell, why unit conversions of metric system is so easy. Why the metric system is so much better. Because when I multiply this, it's very easy to multiply. When I divide these, it's very easy to divide. All right, let's take a look at the next problem. 1 centimeter is equal to, or let's convert 1 centimeter into how many millimeters, right? 1 centimeter, we're going from centimeter to millimeter. Now actually, if you look at our chart, I already wrote down that 1 centimeter is 10 millimeters. So we already know the answer. What we want to do is prove to ourselves that this is true. So let's go ahead and do that here. What we have is we can write down what we are given. We have 1 centimeter. And what we want to do is try to find a conversion factor that goes from centimeters to millimeters. Now, here we actually already have it. We already have the answer. We know that this is the answer, but we want to show and prove to ourselves without using that. So instead of going straight from centimeters to millimeters, is there any other way I could get to the answer? Well, I could go from centimeters to meters, and then once I'm at meters, I could go from meters to millimeters. So you can do these conversion steps in jumps. All you have to do is jump through the tables from one unit to another. All right? So if I want to go from centimeters to meters, I know that there's 100 of these centimeters in 1 meter. So I'm going to write it down like this. 100 of these centimeters are in 1 of these meters. Now, why am I writing it down this way? Because if I flip it over with centimeters on the top and meters on the bottom, nothing will cancel. But this way, the centimeters here will cancel with the centimeters there. Now, if I stop the conversion here, if I just do the calculation, I'm going to end up in meters. But I don't want to go to meters. I want to go to millimeters. I know that 1 meter is 1,000 of these little bitty millimeters. I have to put the 1 meter on the bottom and 1,000 millimeters on the top. Why am I writing it this way? Because if I write it this way, I have this meters canceling with this meter. If I flip it over with 1,000 millimeters on the bottom, nothing will cancel. So this is the only way to make sure that everything cancels and all I have left is millimeters. That's where I want to go. Now, how do I figure out the answer? I have to multiply everything on the top and then divide by everything on the bottom. So here I have 1 times 1 is 1. And then 1 times 1,000 on the top will be what? 1,000. So I'll have 1,000 on the top. And on the bottom, I'll have 100. I have to multiply everything on the bottom. 100 times 1 is 100. So what I have is 1,000 on the top and 100 on the bottom. So 1,000 on the top and 100 on the bottom. Remember, I told you the same thing. If you have trailing zeros like this 0 can cancel with this one. This 0 can cancel with this one. The answer that I get on the top is a 10, and on the bottom is a 1, and 10 divided by 1 is 10, and the unit is millimeters. And what we're saying is that 1 centimeter is 10 millimeters. 1 centimeter is 10 millimeters. So we've proven that what is in this chart is correct, but not by using this line, by using everything else. And so what we did is we said, well, we go from centimeters to meters, and then we go from meters to millimeters, and then we multiply everything on the top, multiply everything on the bottom, and then we do this division. But when we divide with trailing zeros like this, we can cancel the trailing zeros, and then it makes everything simple. I don't have to do any like super hard division because dividing by 100 is really, really easy, right? Last thing I'll say is you can think of this two ways. You can think of it as multiplying the tops, multiplying the bottoms, and then dividing, or you can think of it as 1 times 1 is 1, then divide by 100, then multiply by 1,000, then divide by 1. So it's the same thing, it's just in a different order. So 1 times 1 is 1. If you divide by 100, 1 divided by 100, if you do the long division, you'll get a decimal. If you take that and then multiply by 1,000, then you'll get the answer. But doing it this way is easier. If you multiply the tops and multiply the bottoms, then you'll get to the answer because you can cancel these things much, much faster and much, much easier. All right, with more practice comes many more skills. So let's continue along. What about 3 kiloliters? Let's go to milliliters. So what we want to do is write down what we have been given, 3 kiloliters. Now we want to try to find a conversion that goes from kiloliters to milliliters. That's kiloliters, liters. There's no conversion that goes from kiloliters directly to milliliters. So we can't do that. Is there another path to the answer? We can go from kiloliters to liters, and then from liters to milliliters. So we do it in 2 steps. So we know that 1 kiloliter is 1,000 liters because kilo means 1,000. So 1 kiloliter, we write it down on the bottom, is 1,000 liters. We write it down this way because this is the only way kiloliters cancels. If we stop the calculation here, we'll just get liters, but we don't want liters, so we continue. We go from liters to milliliters. Liters to milliliters. 1 liter is 1,000 milliliters. Okay, we're at 1 liter on the bottom, 1,000 milliliters on the top. Now, liters cancels with liters. We wrote it this way. If we flipped it over, nothing would cancel. We have to write it this way to make it cancel. And so everything is canceled except now we have the unit at the end that we want. The reason we're doing all this, by the way, is because it's hard to know, do I multiply or do I divide by these conversion factors? And this way of doing it makes it very easy. You don't have to guess. You always know what to do because this is the only way that it can be written down to get the right answer. Now, how do I finish it? Well, I say I have on the top 3 times 1,000, and then I have to divide by 1. That's not going to change anything. And then multiply by another 1,000, and then divide by 1. That's not going to change anything. So the dividing by the ones isn't really going to do anything. So 3 times 1,000 is 3,000, right? So what I have here is 3,000. But I still have to multiply by another 1,000. Now, how do I do this? Of course, I can write it all down and do all the long multiplication, but I know that when I multiply by a power of 10, all I have to do is write down, essentially cover up the zeros here. I'm multiplying by 1, so I'm going to get 3,000, and then I'll just add these zeros back in, 3 more of them. And so it's going to be 3 million, and the unit here is milliliters. So the unit is 3 million milliliters. Another way to look at it is I can multiply this, and 3 times 1 is 3, and I add 3 zeros to the end. And then I take that and multiply by 1,000 again. I'm multiplying by 1, so that makes it 3,000, and then I add the zeros in again. So basically, when you multiply by 1,000, you just kind of cover up the zeros, multiply by 1, and then add the zeros back in at the end. That's all you're doing. So that's why there's 6 zeros here, because there's 6 zeros throughout here. Now, does this make sense? Let's see if this actually makes sense. We're saying 3 kiloliters is 3 million milliliters. Okay, 3 kiloliters is 3,000 of these liters. And every one of these liters has 1,000 of these milliliters. So it makes sense that 3,000 of these liters would yield a huge number of milliliters. And that is exactly what we found. All right, let's move right along to problem number 5. What about 42,000 millimeters? And let's convert that to meters. So first we write down 42,000 millimeters, and we want to convert that to meters. Now let's think about it. Can we figure it out without looking at the chart? Well, milli means 1,000 times smaller. So if I'm going from millimeters to meters, I think there's 1,000 of those little bitty millimeters in a meter. Let's see if we're right. 1,000 millimeters is equal to 1 meter. That's the conversion factor we want to use. And the only way we can write it is 1,000 on the bottom millimeters is 1 meter. That's the only way it works, because if we write it upside down, we won't cancel anything. Here we cancel millimeters. And so we have 42,000 times 1, and we have to divide by this. So let's write it. We multiply the top, we're still going to have 42,000. And on the bottom, we have 1,000. All right? And so what do we get? We can cancel this 0 with this one, this cancels with this one, this cancels with this one. What do I get? 42 on the top divided by 1 on the bottom. And so the answer I actually get is 42, and the unit left over is meters. So the answer is 42 meters. All right, cruising right along, making a little more progress now that we know what we're doing. 800 centigrams, let's convert that to milligrams. Now I don't have a conversion that goes straight from centigrams to milligrams, right? But I do have something that goes from centigrams to grams, and then once I'm in grams, I can go from grams to milligrams. So that's what we want to do. We want to do it in 2 steps. 100 centigrams is 1 gram. So let's first write down what we know. 800 centigrams, oops, not centimeters, centigrams. Centigrams. And we just said that 100 of these little centigrams is 1 gram, right? And we have to write it like that because that's the only way that centigrams will cancel. If we stop the calculation, we'll be left with grams, but we don't want to stop there. We want to go from grams to milligrams. 1 gram is 1,000 milligrams. So we continue our table, we can string them along, and we say that 1 gram is 1,000 milligrams. And then by arranging it like this, if we flip it over, nothing will cancel. Arranging it like this means grams cancels with grams. Now, how do we complete the calculation? Well, first we multiply the tops, right? And by multiplying the tops, we have 800 times 1,000, well, times 1, but that doesn't do anything, times 1,000. But it's easy to multiply that. We just cover up the zeros and multiply by 1, we get 800. And then we have to add these zeros back in, 3 more of them. So this is what happens when we multiply the top. We have to divide by this, but this times 1 is still 100, so it's just going to be 100 on the bottom. Now, we have a lot of trailing zeros. This can cancel with this, and this can cancel with this. And so what's going to happen, on the top, I still have 3 zeros, so that's 8,000, divided by the 1 that's on the bottom. And so what you have is 8,000. What are we talking about? Milligrams. That's the only unit left. Let me check and make sure that's right. 8,000 milligrams. So you see why it's so nice to work with the metric system, because multiplying when you have a bunch of zeros makes it easy to multiply, and then dividing when you have a bunch of zeros makes it easy to divide. And since everything is a power of 10, it just makes it very simple. We have a couple more problems. I want to erase this and continue our lesson. All right, only 2 more problems. Let's take a look at 51,000 milliliters. Let's convert that into the unit of liters. Well, the first thing is we write down what we are given. We're given 51,000 milliliters, and we want to find a conversion factor that goes to liters. All right, we think there is one, so we go back and check our table, and we see that we have milliliters and liters here. 1 liter is 1,000 of these little bitty milliliters. So we know that 1 liter is 1,000 milliliters. The only way we can write it is with 1 liter on the top and 1,000 milliliters on the bottom, because if we flip it over, nothing will cancel. This is the only way the milliliters cancel, leaving us with liters. So all I really have to do is take the 51,000 times the 1, which is just going to be 51,000. And on the bottom, I just have 1,000. And now I have to do this division. But I have a lot of trailing zeros. This cancels, and this cancels, and this cancels. And all I really have on the top is 51, and on the bottom, I just have a 1. And so that's divided by 1, so it's 51, what? Liters. And the answer is 51 liters. And that's the final answer. Here's our last problem for this lesson. We have 19 kilograms. Let's convert it to centigrams. Kilograms to centigrams. We do not have a direct path from kilograms to centigrams, but we do have a path from kilograms to grams, and then once we get to grams, we go from grams to centigrams. So let's start by saying 1 kilogram is 1,000 of these little bitty grams. Let's write down what we are given, 19 kilograms. Extend our table, and we want to write down now that 1 kilogram is 1,000 of these little bitty grams. We have to write it that way because it's the only way the kilograms cancel. Now going from grams to centigrams, let's remind us what that is. 1 gram is 100 of these little bitty centigrams. Right? So we go and say, well, 1 gram is 100 centigrams. This is the only way I can write it because I have to have a gram on the top and a gram on the bottom to cancel. Now I am left with the unit I want to calculate. So how do I finish the calculation? I have to multiply the top and then I divide by the bottom, but 1 times 1 is 1, so dividing by 1 is going to do nothing. So really, I just have to multiply the top. So here I have 19 times 1,000. What is that? Well, you just cover up the zeros. 19 times 1 is 19, and then I just add the 3 zeros. And then I still have to multiply by this 100. What is this times 100? I just cover up the zeros, multiply by 1. It's going to be 19,000. And I covered it up here, and I have to add these zeros back in. So I add 2 more zeros at the end. So here's a comma, and then here's a comma. 1,900,000, and the unit I'm talking about is centigrams. So you see, multiplying by powers of 10, I just multiply by 1, add the 3 zeros. And then I multiply by this one, I multiply by 1, and then add the 2 zeros at the end. So basically, when you multiply by 10 or 100 or 1,000, you just essentially write down what you start with and you add zeros at the end. It's very simple. And that's why unit conversions in the metric system is so convenient. When we get into science and engineering and astronomy and things like that, we only use the metric system. Because this table, remember in the beginning I told you, this entire table, all it has is tens and hundreds and thousands and things like this, and it makes it very easy to calculate. So I want you to practice every one of these problems. Really want to make sure you understand how to set these tables up and how to know what to do. The whole reason we're doing this table is because if you're trying to go from kiloliters to milliliters and you don't do it this way, then you're going to find yourself not sure what to do with the conversion factors here. You're not going to be sure if you should multiply or divide. It's going to be hard for you to figure it out what to do. But if you just put down what you are given and then write each conversion in a way that gets you down to where you're trying to go, then the table tells you if you should be multiplying or dividing. And you will always get the right answer. And as we move into chemistry and other classes later, we're going to use all of this in every single problem. So this stuff you're learning, you'll use it for years and years and years. So I'd like you to practice it. Follow me on to part 2. We'll get a little more practice.